To demonstrate the YAWL environment, we'll use a small example which we'll explain in the following couple of slides. The example captures a process containing a double check activity. This could be, for instance, an insurance claim process containing 5 tasks, or registration of an insurance claim, then a check A and a check B, or check A can be a check of insurance policy, while check B the check of damage reported. Then we have approval and rejection. As shown in this diagram, the registration is done first, then check A and check B can be carried out and possibly in parallel. When both checks gives a positive result, the application is approved, otherwise it is rejected. Furthermore, what is not shown in the diagram is that there are 3 rows, one for customer service performing the task register, then a specialist A for performing check A, a specialist B for performing check Bs, and then again the customer service performing approve or rejection. Important for this process is to note that if any of the checks fails, then the other check is not carried out. This is in order to save resources. Now let's see how this example is modeled in YAWL. First, the task register inquiry is introduced. Then a task check A1 and another task check 2 are introduced. After that, we have task send approval to customer and send rejection to customer. And all these tasks are connected to each other with arcs. To show that check 1 and check 2 tasks can be run in parallel, the task register inquiry is decorated as an end split task. When both check 1 and check 2 are fulfilled successfully, then send approval to customer is enabled. However, if any of the checks is not fulfilled, is not successful, then the cancellation task is performed. And the cancellation is drawn in order to show that the moment one of the checks fails, the other one will be cancelled. And this is shown by including these different checks into the cancellation region of the task cancel. And in the figure, the cancellation region is shown with red. When the not completed check is cancelled, the rejection is sent to the customer. The control flow of a process is defined in the YAWL editor. The behavior of the YAWL editor will be shown or demonstrated in a different tutorial. Now let's have a look at the organizational model for this example. We do have a very simple organizational model. We have 3 roles specified, which are customer service, specialist A and specialist B. And let's define a few users. Let's say that Anne and Adam belongs to the customer service, Beat and Ben are specialist A, Beate, Carol and Chris are specialist B. And in this case, I wanted to show that Beate is both specialist A and specialist B. The organizational model, which contains role, actors, etc., is defined in the YAWL control center. The behavior of the YAWL control center will be then demonstrated in a different tutorial. After the control flow of a process has been specified and the organizational model defined, the tasks are allocated to the resources. In our small example, as shown in this figure, register inquiry is associated with customer service. Check 1 and check 2 are distributed to specialist A and specialist B correspondingly. And finally, sent approval and sent rejections are assigned to customer service role. In addition, we have a business rule stating that the task send rejection to customer shall be performed by the same actor who earlier carried out the task register inquiry. This is to ensure that the actor delivering the rejection will be familiar with the entire case. Note that in this notation, or the notation used here, it's actually not part of the YAWL notation. It is very simplistic, swim lane similar notation, and it can only express very simple rules. Rules like the one we have here, that send rejection have to be performed by the same actor who carried out the task register inquiry, cannot be really expressed in this notation. They are just noted in natural language. How these are captured in YAWL will be shown or demonstrated during the tutorials for the YAWL editor. The resource allocation of tasks is defined in the YAWL editor through a Managing Resources wizard. These two will be introduced in the tutorial for the YAWL editor. After the control flow of a process have been defined, the data uses input for or generated as output from the different tasks is specified. This can be done both before or after the resource allocation has been done. Here we have done it after. The figure shows that during the execution register inquiry, the customer name is entered. During the execution of task check 1, the customer name is displayed, and then the result from the check 1 is entered. Similarly, during the execution of check 2, the customer name is displayed for the user and the result from the check is entered into the system. Sent approval displays the customer name, while sent rejection displays the result from the different checks in addition to the customer name. In this figure, we have used red arrows with accompanying data descriptions in red to denote the data entered during the execution of a task. In reality, this is the output data from the task, which means that this is the data gathered as a result of the execution of a task. In addition, data description and green arrows are used to denote the input data to a task, which is usually displayed to the actors executing the tasks. This notation too is slightly simplistic, and it is actually not part of the YAWL notation. Data in YAWL is defined at case level when the data flowing to and from the different tasks is explicitly defined. All data definitions are done in the YAWL editor. This too will be exemplified during the tutorial for the YAWL editor. Note that the data used in this example is minimal, similar to the whole example. However, it is enough for exemplifying the basic ideas of data manipulation in a workflow management system. The red and green arrows are, again, not part of the YAWL graphical notation. A disadvantage with this way of visualizing data is that the model gets easily cluttered as more complete and detailed data is added to it. Furthermore, the red and green arrows in the figure are too simplistic to capture the complete data handling supported in YAWL. How data is captured in YAWL is demonstrated in another tutorial.